special angle relationships occur when we have two lines, such as these two, being intersected by a third line known as the transversal. Sometimes the two lines being intersected by the transversal are parallel, meaning they'll never intersect. And sometimes they're not, but you just can't see them intersecting at the moment. The lines being intersected by the transversal create internal and external areas. What do I mean by that? The place inside these two lines is the interior. The angles that occur on the outside of the two lines being intersected by the transversal are known as exterior angles. I like to imagine it as a river is in between the lines that are intersected. And out here we have the riverbank. And what would the transversal be that is crossing over the river? Well, I like to call that the bridge. Now there are several key words we'll be using. Besides interior and exterior, we have the following: consecutive, which means on the same side of the transversal. And we have alternate. That means on the opposite sides of the transversal. So the angles that I see here in red, they are both inside the river. They are both interior. But are they on the same side of the bridge, or are they on alternate sides of the bridge? Well, they are on alternate sides of the bridge. So these two red angles are known as alternate interior angles. Another pair of alternate interior angles looks like this. Same angle relationship, because the red angles are occurring in the river, so on the interior, and they are on alternate sides of the bridge, of the transversal. These angles are occurring on the exterior. Both occur on the riverbank. These are exterior angles, but are they alternate exterior angles, or are they consecutive exterior angles? Alternate would be on the opposite sides of the bridge, and consecutive would be the same side. That looks like alternate to me. There's another pair of alternate exterior angles right here. They are on opposite sides of the bridge, but they're also on the riverbank, the exterior. So these are also alternate exterior angles. These angles occur in the river. They are both in the interior. Now the next question is, are they on the same side of the bridge, meaning consecutive, or are they on alternate sides of the bridge? Looks like these are on the same side, so consecutive interior angles. Here we have another pair of consecutive interior angles. They are on the same side of the transversal, and they are interior in the river. I have some more exterior angles. Both of these angles occur on the riverbank, which would be the exterior. And now I need to determine if they are alternate exterior on alternate sides of the transversal or on the same side. Are these on alternate sides of the bridge or same side? These are on opposite sides of the bridge, so they are alternate exterior angles. Here is another pair of alternate exterior angles. They occur on opposite or alternate sides of the transversal, but they are on the exterior of the lines being intersected by the transversal, also known as the riverbank. Here we have some more exterior angles occurring on the riverbank. Are these same side exterior angles or alternate exterior angles? It looks like they are on the same side. What do we call that? Consecutive. These are consecutive and they're exterior because they're outside of the river. Here is another pair of consecutive exterior angles. Same side of the transversal on the exterior of the lines being intersected. Now it's time to review my personal favorite angle relationship, which is corresponding angles. The transversal creates two major intersections. I'm going to label each of the quote quadrants or angles that are created by the intersections, and I'm going to label them 1, 2, 3, 4 in this counterclockwise manner as I'm used to from Algebra 1. So this top right corner I'm going to label 1. Then I go to the top left corner and I'm labeling that 2. The bottom left corner is 3. The bottom right corner is 4. So now I need to label the exact same numbers in the exact same places on the second intersection. So the upper right corner will be 1, upper left is 2, lower left is 3, lower right is 4. Same orientation so that they perfectly correspond. This means that angle 1 and angle 1 are corresponding angles. Angle 2 and angle 2 are corresponding angles. They're in the top left corner, same orientation. Another thing about corresponding angles is one of them is always in the river and one of them is always on the river bank. Number 3, we have the bottom left corner. So number 3, bottom left corner, 1 in the river, 1 on the bank. And 4 is the bottom right corner. And so at our other major intersection, the corresponding angle is the bottom right corner. We have another relationship called supplementary. Supplementary angles are two angles whose sum is 180 degrees, and supplementary angles do not need to occur on, a diagram where two lines are cut by a transversal, but they can. So please know that if you have two angles that make up a straight line, or two angles that make up a semicircle, they're right next to each other. These angles are also supplementary because a straight line does give us an angle of 180 degrees. And if these two angles make up a straight line, 180 degrees, then they are supplementary. So we know a straight line produces a 180 degree angle. If I draw another line that intersects this one, now I've created a pair of supplementary angles. This angle and this angle are supplementary. In fact, I'm going to give them a name. This one will be called x, so this angle is x, and this angle is y. Can I create an equation with x and y? I may not be able to solve for x and y, but I can create an equation because this is angle addition. Part plus part equals whole. And for supplementary angles, the whole is always 180 degrees. Okay, so x and y are supplementary. They add up to 180 degrees. This intersection actually creates several supplementary pairs. I'm going to point out one of them. This right here is an angle made up of a straight line. In fact, it's also made up of two smaller angles. Okay, so we have this angle. Hey, we already have a name for that. That's x. And then we have this angle. I don't have a name for that one. I'll call it z. This x and z are also a pair of supplementary angles because they are two angles that make up a straight line, and a straight line is 180 degrees. Supplementary angles are two angles that add up to 180 degrees. So let's write an equation for x and z. X plus z is 180 degrees because part plus part equals whole. So what do I have? I have two equations with two variables in them, but each of them has an x. Okay, so let's see if we can solve each of these equations for x. So first I want to get x completely by itself. Y is being added to x, so I want to subtract it on this side of the equation, and I also need to subtract it on this side as well. So I have x is equal to, now I can't combine 180 with y, so 180 degrees minus y. Let's solve for x in our second equation. Same thing, z is being added to x, so I will subtract it to bring it to the other side of the equation by inverse operations, which makes x equal to 180 degrees minus z. Okay, we rearranged it, but how does that help us? Well, x is equal to 180 degrees minus y, and x, the very same x, is equal to 180 degrees minus z. So, if x is equal to x, then 180 minus y is equal to 180 minus z. This is by system of equations. It's called substitution, or sometimes referred to as equal values method. This is an interesting looking equation. I can't put y and z together, but I could get the 180 to combine, so I'll subtract 180 on both sides. Oh, now I don't have 180, I just have negative y is equal to negative z. That's interesting. If negative y is equal to negative z, I could potentially divide both sides by negative 1 and then get that y is equal to z. That y is equal to z. Angle y is actually equal to angle z. Angle y is equal to angle z. These give me the same exact measure. Now, knowing what we just found out, let's find the measures of angles Q, R, and angle S. If I take the 50-degree angle and I turn this into a semicircle or add it to another angle to make a straight line, then I know that those two angles are supplementary and they add up to be 180. So 50 plus Q is equal to 180 degrees. When I subtract 50 on both sides, I get Q is equal to 130 degrees. Good to know. Now I could use the relationship of supplementary angles, but I also learned something very special about anytime you have an intersection of two lines, it forms four angles, right? The angles that are found across from each other, okay, across the intersection, across the X, so not next to each other, they're across the X from each other, those have a special relationship. Those are always equal in measure. The geometry word for equal is congruent in measure. So if this angle is 50 degrees, this angle is 50 degrees. And if this angle is 130 degrees, this angle is 130 degrees. Now, is there a special name for this relationship? Yes, I said they're congruent, which means they're equal measure. But what about this special, the angle across the intersection, the angle across the intersection? So not right next to, but in the same intersection. So is there an angle relationship name for the pair of blue angles and the pair of green angles? Yes, there is. Those are called vertical angles. Here we have a pair of vertical angles. The blue angles are vertical and they are congruent, meaning they are of equal measure. The orange angles are also congruent of equal measure. They are also known as vertical angles because they are across the intersection, across the X from one another. And just as a recap, supplementary angles could be two angles that make up a straight line, which would mean they're two angles that make up 180 degrees, which is the meaning of supplementary. But also those supplementary angles, they don't have to be touching one another. They do not have to happen at an intersection. Vertical angles have to happen at an intersection. That's their special relationship, is that they occur opposite an intersection from one another.